Hello friends, we are now going to discuss about the basics of the magnetotelluric method as part of the lecture 1. So it will be covering under the electromagnetic theory, the electromagnetic field setup, and we'll also discuss about the derivation of the impedance tensor from the electromagnetic theory, the types of empty surveys and the depth parameters. The case studies and the instrumental setup also will be describing. So you can see the instrument and the field setup it is. You can easily see the electrode pot. So let's discuss in detail about. So first let us talk about the electromagnetologic method. What is this? You know it's a state-of-the-art technique for mineral exploration, and basically it's a passive electromagnetic technique measuring the natural variation of the Earth's electric and magnetic field. So there are different types of empty survey. Based upon your objective and target, these types of empty survey can be chosen. So as an example, if you want to target for the shallow depths, so you have to choose the high frequency range. And for intermediate depth and the frequency, you choose the broadband type empty surface. And whenever you target the very deeper surface, that's the lithospheric survey, then you need to record for longer period of time. So the basic outcome it can the possible concealed and the deep seated mineral deposit, and it will be better if you can integrate with other geoscientific data. So it can give extra information. So the basic frequency range is 10 power minus 4 to 10 kilohertz with the investigation depths of tens of meter to the hundreds of kilometers. So this slide is very common to you. I have delivered this slide as a basics of the electromagnetic method. So this is a passive electromagnetic method. There will be long period, short period waves, and there will be component of electric field and the magnetic field. The resistivity, our basic objective will be to derive the impedance tensor and resistivity and the apparent resistivity, which is dependent upon the mod square of the Z. So in detail, I'll be discussing about this, all the things. And the pictorial description of the empty pattern is always there. The solar wind, there will be electromagnetic wave. The ionosphere, it will be reflected back to the earth. And that is a passive electromagnetic signal and that will be recorded. So there will be a frequency range of below 1 hertz and greater than 1 hertz with the greater probing depth and the lesser probing depth. So whatever the electromagnetic wave that will be generated by that source, solar wind and thunderstorm will travel inside the earth. So they will encounter various types of rocks. The rocks will produce the secondary electromagnetic field, and depending upon that we can measure the resistivity of the rock, and that will be dependent upon the secondary electromagnetic field. So there are short period, long period, and the intermediate period electromagnetic wave. And based upon that, you can nomenclature is as a short, it's a audio magnetotelluric, it's a broadband magnetotelluric, and this long period magnet. So this is the basically it's a tensor electrical impedance that we need to measure the time varying electromagnetic field, and that can use computer modeling of the cross section. But seriously, what can it tell about the earth? So it is a very important things. It can give information from the earth's crust to the upper mantle. It has been used successfully to locate the thrust sediment, under thrust sediment, the regions of the metamorphism, the partial melting, and also the fault fracture zones as part of the geology. And similarly for mantle, it can give information of the partial melt, the variation in the lithospheric temperature, and also some information about the asthenosphere. So you can see the depth of investigation of the magnetological survey depend upon the frequency and the resistivity. So if you have higher frequency, it can image near surface, and the lower frequency can penetrate to the greater depth. Higher frequency means higher resistivity means deeper penetration. This is the skin depth, so it is proportionate to the root over of the frequency and the inverse of the resistivity and the inverse of the frequency with the constant factor of 500 almost. So mu and mu0 is the standard magnetic permeability and the permittivity of the free space. So based upon that, you can see three types of survey, and there are the frequency ranges from 10 per minus hertz, 4 hertz to 10 kilohertz. There will be a skin depth. So for long period survey, there's a maximum skin depth, that maximum it can probe, that is a 500 km. And depending upon that, you can have different data recording duration and the different station spacing, which is the variable based upon your target. You can choose these parameters and optimize these parameters. So the basic governing equation is the the Faradayson curl of E is j omega mu h and curl of h. So this type equations I have already told about in my previous electromagnetic lecture. So component wise you can derive this equation. Now you can see for half space, assuming the half space, and you can see the vertically propagating plane wave, you can have no component of electric and magnetic field along the z direction. So inserting this input into the equation, you can have this type of equation. And from that you can have the second order partial differential equation. That's almost like a say, the del 2 ey by del z2 plus j omega mu sigma. So we can have assume the solution in the form of e to the power I kz, and assuming k this value can get the final result. So our objective will be to derive the tensor component of the impedance. So that will be basically the ratio of the ey by hx or eh, or you can have zxy means eh by sy. So the amplitude is proportional to the frequency and the resistivity. This leads to the apparent fact concept of the apparent resistivity. So basically the apparent resistivity is proportional to the mod square of the impedance value, and it is represented by the phase and the amplitude. That is the so for typical empty setup, you can have two horizontal components, electric field Ex and Ey, and three magnetic field components. But there is also a vertical component of electric field. Generally, it is not measured because it is reflected by the air-earth interface. So there will be two channels for the electric field, three channels for the magnetic field. So total 8 channels. That's why I'm telling you total 8 channels for simultaneous empty measurement. So for 8 channels, for 6 magnetic fields, there will be three induction coil magnetometers, this 336, and three flux gate magnetometer for if you want to measure the long period magnetotelluric wave, very crustal variation. So these are the basically electric field component. This is the logger electric field X component of the electric field. This will be the Y component of the electric field. This is the induction coil HX, HY, HZ. And if you have, the long period wave, you can measure also the flux gate component. Similarly, HX, another pair of HX, HY, HZ. So during the practical, this is the practical field setup. Whenever you are, installing the empty instrument, the you need to remember you have to protect the equipment from the wildlife, livestock, and the vegetation. For the defining the survey design, 2D, 3D. In this type of survey, you can have a data logger. From 50-meter distance, there will be EX dipole and there will be EY dipole, and there this angle is 180-degree. So there will be a HX, the coil induction coil HX, HY, and there's a vertical magnetic coil will be there, HZ. So magnetic north is along this direction. You have to then calibrate the receiver and sensor and can run overnight. So now let's have a pictorial representation of the 8-channel magnetic uh, magnetotelluric instrument. So there is the EX, there will be EY. This is the EX, there is the dipole EX, the two connections. For EY, these two connections are there. And for three magnetic field components, this is HX, this is HY, this is HZ, and the battery is connected. And this is one of the example of the sensor HX or HY, anywhere around. The SD card is inserted in that to acquire the data, and there will be also flux gate sensor is in that H4 H5, H4 H5 is Z, the flux gate magnetic coil. So there will be total 2 plus total 8 channel, 2 plus 3 plus 3, 2 electric field, 3 magnetic field for induction, 3 magnetic field for flux gate. So this is the HZ sensor placed vertically. So this is one of the non-polarizable electric pot, and SMS Typical example of flux gate sensor. The north is along this direction. Now the whole setup is just pictorially shown in there. So the magnetic coils, mm, the flux gate sensors, the two batteries that will be and the two batteries you need to carry these two batteries in pair, so that if one just get exhausted, you can use another one. And this is the 8 channel instrument and all setups, the coils, the sensors, the electric ports, the batteries, and the channel. So ensure if you are going to the equipment, check and test all the equipments to go to the field. So this is all about my lecture. So I'll recommend you to just go through my electromagnetic lecture before jumping in this lecture. The link will be shared. So if you like it, you can share, like, and follow this. And this is my channel, Physics and Geophysics Learning with me. Good night.